All right, I'm gonna go ahead and get started and do a little workshop on enabling account abstraction on Athena today with ZeroDev. And the main thing that I'm going to demonstrate is paying gas with USDe. And yeah, to give a little bit of background about like what is ZeroDev, who is ZeroDev. We're a smart account company that offers smart accounts for Web3 experiences. Some like the main things that we would offer are gas sponsorship, transaction batching, session keys, account recovery. Recently, we even got into chain abstracted smart accounts and some offerings around that space. And then a little bit about us as a leading solution in account abstraction. ZeroDev ZeroDev powers over 50% of AA wallets and drives a significant amount of DeFi transaction volume. But with that said, to talk about what we're going to do today, the plan is to create a kernel smart account. Kernel is the name of the smart contract account that was developed by ZeroDev. And we're going to create this account on the BLE testnet that can sponsor transactions with USDe. And we're actually going to use our new offering, which is a self-funded Paymaster, which we just launched this week. And yeah, to give a little context, not sure if everybody knows really what a Paymaster is. So Paymaster is part of the ERC 4337 account abstraction ecosystem. This is really like the spec for the infrastructure and interface for creating smart accounts on Ethereum or EVM-based blockchains. And a Paymaster is actually a smart contract that sponsors transaction gas for users. And it does so by verifying and approving user operations before submission. A good benefit of this is it also enables users to pay gas fees and tokens that are other than Ether or like the native token of the chain that you're using. And yeah, it really like facilitates a seamless user experience by abstracting gas payment complexities. I'm sure a lot of you have seen in a lot of apps that have been spun up in the past year, you could like sign in with a social account, and then you can have your transactions go through without you paying any gas fees yourself. And that's all mostly done through ERC 4337 and Paymasters. But yeah, I don't want to spend too much time just like talking about the high level stuff. I want to actually get into a demo of the functionality. And there's two parts to this really. We're going to start out in the ZeroDev dashboard, and we're just going to set up our account, create a project, and then deploy the Paymaster contract so that we can sponsor these transactions. And then from there, I have a repo that I set up with just like a simple script that could show you how to send a transaction that is sponsored with USDe. So yeah, let's go ahead and get started with that. So I've already got the dashboard loaded up here. It's dashboard.zerodev.app. Yeah, this is just like a personal account that I have. If you create an account for the first time, you won't see a project here. You'll have to create your own project. So I'm going to create like you can see I have a bunch of just test projects here, but I'm going to go ahead and create another test project. This example. And we'll use the test nets. Go ahead and create this project. Yeah, so now with like ZeroDev, you're actually all set up with a project ID that you could use with our SDK to sponsor transactions. Since this is a test net, most test nets like you would actually be able to just go ahead and use right away to sponsor your transactions. But since this one only supports self-funded Paymasters, I'm going to go ahead and demonstrate that. This new feature that we launched, which we can set up in this tab to the left right here. And we're going to focus on the ERC20 Paymaster since we're sponsoring with USDe. And in order to do that, oh yeah, just to give like another like little high level bit. So normally, as I mentioned, like ZeroDev does sponsor gas. It fronts the gas for users and like would charge your user's credit card that you put down. But we've had a lot of people that have just wanted to like fund their own Paymasters so they don't have to use credit cards and whatnot. So this self-funded Paymaster can allow you to actually fund your own Paymaster contract that then gets used like under the hood. And so, yeah, I'm going to go through the steps of actually like setting up that Paymaster and funding it, and so on. So yeah, we'll focus on this ERC20 Paymaster down here. Go ahead and deploy it. I already connected my MetaMask and connected to the testnet. I do have ETH in the account, so I can go ahead and deploy the contract. It will take a second to load up. But cool. So now we have the contract address here, which deployed on chain. But the next thing is, so the Paymaster, as I said, like will kind of like front funds for user operations or transactions when they get sent. In order to do that, it needs to have a balance. So I'm going to go ahead and load this Paymaster contract here with a little bit of ETH so that it can pay for transactions. This ETH will get used to front the gas for these transactions, and then whoever sent the transaction will have USDe in their account, and the Paymaster actually pays itself back after the transaction goes through. So yeah, to get started, I've got to add an amount here. I'm just doing a test, so we don't need much. Confirm it. Yeah, this will take a sec. Yeah, while that's loading, I will tap. There we go. So yeah, now we have 0.01 ETH that is deposited into the Paymaster contract, and we'll use this balance to pay for the gas fees for transactions that get sent. But next up, whenever you send a transaction, you need to know how much you're going to pay yourself back with whatever ERC20 that gets used to fund the transaction. So right now, we need to go ahead and create like an exchange rate for USDe. This is, at this point, like I said, this is a new feature. We're still kind of iterating on it. So this is a little bit of a manual step here, which we will improve. It's on a roadmap where you set a conversion rate for 1 ETH to USDe. I know this isn't ideal because obviously prices fluctuate. They've been fluctuating a lot recently. But for the sake of like the current implementation, I'm going to go ahead and set a conversion rate. I need the contract address real quick. So I'll go ahead and enter the token address for the testnet here. Set a symbol E, and I think right now it's around like 2,800. But yeah, I can go ahead and create this. Yeah, so at this point, our self-funded Paymaster is completely set up. We're good to go as far as like the ZeroDev dashboard aspect goes. We can transition on over to our script, which uses like the ZeroDev SDK in order to send transactions that are sponsored. And in order to do that, I did leave this up for a second if anybody wants to go to this address. But I do have just like a small repo with the script set up that I'm going to be using. I could share it after the workshop as well if anybody wants to clone it and run it themselves. But yeah, I'll go ahead and get started with the next part. Yeah, and I did put all of these steps into the README in this repo. As you can see, we kind of have already done the prerequisites. We created an account in the dashboard, we deployed the Paymaster, and we set a conversion rate. So yeah, next up, we're going to go through actually sending our first transaction. I added 2 scripts in the package.json. One's to get an address, and one is to actually send the transaction. I'm going to go ahead and do this get address first, The reason that I need to do this is the smart contract account will be basically counterfactually, like the address can be counterfactually calculated. And in order to send transactions, we need to have a USDe balance at that address. So before I can do anything, I need to actually get the address of the kernel account, and then I need to send USDe to it so that it can pay for its own transactions. So I'll show the script after this, but yeah, right now I'm just going to run to get the address. And yeah, I've already got the USDe loaded up in this account. I'm going to send some. Got a lot of accounts here, and yeah, I'll just send like 5 for now. Alrighty, so while this gets going, I will move back over to the script and we can kind of talk through what we're actually doing to send the transaction. So example here, we do have to load up a couple of variables in order for this to work. We'll need a bundler RPC, Paymaster RPC, and a private key. And for the sake of this script, I've created an environment file. This is a random, I just generated this private key, so I'm not concerned that I'm sharing it publicly. But yeah, so you'll go ahead and have to put your private key in here, or a private key. This private key will be the owner of the smart contract account. And this is the key that will be used to sign ECDSA signatures on behalf of the account to approve transactions and do things on chain. As far as the RPCs that we need, we're going to need a bundler RPC and a Paymaster RPC, and we can get those from the dashboard with the project that we just set up. So the Paymaster URL, we can actually just copy from here in the dashboard. And then for the bundler RPC, the big thing, it's really just the difference in the URL is just bundler here. And then I'm just going to take the project ID. You can also copy this from dashboard back in the home, bundler RPC, but just did that. Yeah, so now we have the config that we need from the dashboard. This is, yeah, really all that we need there. So we can go back to the script and we can go through and yeah, I'll talk through kind of like what this script is actually doing. I have a constant here, just saved the USDe address on the chain, which is just the ERC20 address. This testnet is not in Veeam yet, so it's not like exported from Veeam chains. So we went ahead and created our own chain objects that we could use throughout this file. And then, yeah, public client, this is going to send public RPCs. This is all really just kind of like boilerplate, like setup of the script. And then create the signer with the private key that we just set in the environment file. And this signer object is going to be used to sign the transactions that get sent. But now let's get into the meat of it a little bit. So this is code. It's like very well documented in the ZeroDev documentation site. But yeah, obviously feel free to use this script as well. But so to go ahead, we're going to use the signer to create an ECDSA validator. And this validator is what's going to be used within our account object, which is a kernel account object. Since it's sudo, this is like the main signer for the account. It has sudo permissions for it. And then we'll go down here to our send transaction. This is where we create our Paymaster client, and it's using our Paymaster RPC. This is basically the RPC endpoint that gets called to check whether or not we have a self-funded Paymaster. If so, is there balance in the Paymaster? and does that Paymaster contract approve whatever transactions get sent. So we'll use that Paymaster client to, down below, create our kernel account client. In the terminology of like our SDK, or like the realm of our SDK, this kernel account client is basically the object that has all of the information it needs to send transactions and interact with the kernel smart contract on chain. So as you can see, we pass like a lot of the values that we defined above, such as the Veeam chain, the bundler transport. This is where like the actual user up gets sent to get posted on chain. We have middleware here. This is where we're going to use the Paymaster client so that the Paymaster client can intercept the user up and get a signature saying that this Paymaster contract will approve paying for the fees for this user operation. But yeah, I think that's really the only like important information with that. And then yeah, at the bottom down here, we're going to go ahead and just send our user up. For the sake of this script, it's pretty simple. There's one thing that you need to do when you're using an ERC Tier 20 Paymaster, is you need to approve the funds to the entry point. So this is how the Paymaster contract will pay itself back after it sponsors your user op. So you just need to set a balance here that is higher than the estimated fees for the given user op. And one benefit of using a smart account is that you can like batch transactions. So this is actually 2 transactions sent in one user op. So the first one is setting the approve amount. And then the second one here, just for sake of example, doing absolutely nothing fancy, sending like a 0 empty transaction, sending it to 0 address, no value data. But we can do this, and once it's sent, we'll get our information back and we can go ahead and see it propagate into the block explorer. So I think I've set everything up. I think we're good to go to test it. So yeah, now I'll just run, as I showed earlier, I got like the script in here in the package.json to run the send transaction. So yeah, for those of you that aren't super familiar with the like 4337 account abstraction landscape, when you send a user op, you get a user op hash. This is a account abstraction equivalent of a transaction hash. There are tools out there that are kind of like block explorers for 4337. One of them that's really good that I use a lot is called JiffyScan. So shout out to them. But yeah, so we went ahead, we did also get the transaction hash, which you can see here from the user op receipt. And I'm gonna go ahead and go to the block explorer. And as you can see, we have a successful transaction from our smart account. This 8A6D could show this is the same address as the account here that we funded. And then as far as the gas fees, so you could see on this, we have a tokens transferred. It's a USDe. And for this address, this actually goes to the owner of the Paymaster contract. So I deployed the contract with DF6C, which you can see there. So the Paymaster contract paid itself back with USDe after sponsoring the transaction for my smart account. But yeah, I think that is a end-to-end demo of setting up a self-funded Paymaster and sending a sponsored transaction on the Ethena testnet. I don't really have anything else after that. I can open it up for questions at this point if anybody has any.
Thank you very much, Blake, for that demo. Do we have any questions for Blake about account abstraction or ZeroDev or anything that we've just seen in the demo? Otherwise, we'll wrap up our second workshop of the day now. And if you have any questions, you can put them in the Discord server and we can ask Blake to answer them asynchronously. So as I say, the recording of these workshops will be posted possibly tomorrow, possibly slightly later, because the Encode team is traveling to DevCon tomorrow. So we'll be a bit preoccupied on a plane. But we'll get it to you as quickly as we can so that you can rewatch them. We've got 2 more hackathon workshops tomorrow. The first is run by the Ethena team, and that's at 4 o'clock GMT. And then the second one is about indexing with GoldSky. So they'll be the same time as our sessions have been today and yesterday. And I hope to see, well, actually, I won't be here. My colleague Yasin will be here, but I hope to see your names on the attendance list. And I hope that you enjoy the final workshops in the series. Thank you, Blake, for coming in and giving this demo. And good luck hacking, everybody. Enjoy the rest of your week, because I won't see you until I get in contact with you guys in the next few weeks while you're hacking. But otherwise, it's been a great workshop series so far. So thanks, everyone. Enjoy the rest of your day.
Thank you.